Hi everyone, welcome back to Ultrasonic Engineering Academy. Today I am going to show you how to perform one lab experiment, that is ultrasonic pulse velocity test. In our experiment today we are going to use the test specimen, that is the 150 by 150 by 150 cube. So we are going to use the apparatus that we call it ultrasonic pulse velocity test meter. As you can see, so these are transducers, so there is a receiver and there is a transmitter. So in this video, I will clearly explain for you all the procedure that you need to perform this test. So the first thing you need to do is to make sure that the surface that you're going to put in your transducers in should be what? Should be smooth. So what I'll do, this is our grease. I will have to apply on the surface to make it what? Make sure that it is smooth on both sides. Make sure that your surface is what? Is smooth. So in this test, we actually test for the integrity of the concrete. That is to check for the durability of the concrete, to check how dense the concrete is, then to check for the correlations in terms of the strength of the concrete. So let me show you how you perform it. When the surface is now smooth, the surface of the specimen is smooth, I will take the transducers. So I will put them, because I'm using the direct method. There's direct method, there's semi-direct method, then there's indirect method. So today I'm going to show you how to use the direct method. So you take the transducer, then you put it perpendicular to one another. That means it should be opposite. You put it opposite, that is the direct method. Put it opposite to one another. So if I put it opposite to one another, the reading will come. So as you can see, our reading is constant at 26.6 microseconds, then 3759. Yeah, our reading was 3759 meters per second. What? That's the velocity. So there are two readings. I've got two readings. Number one reading is in terms of microsecond, that is time. So for me to get a velocity from the what? From this, I need to know the length. The length between this is a 150 millimeter cube. So the length, if I divide it with that microseconds that I've got, it will give me the velocity. Or you could consider the velocity direct. So the answers that you will get will really determine what that particular cube, the strength is correlating to. So according to IS 516 part 1 2008, that explains for you the whole thing of carrying out this test. So this test, the result, if it is greater than 4.5 kilometer per second, that result is considered as excellent. But if it is in the range of 3.5 to 4.5, it is considered as good. And most of the structure, most of the structural specimens, or the structure like cubes, beams, most of them fall within the standard of 3.5 to 4.5, which is a good result. And according to our result, ours was coming to 3.7 when you convert that to kilometer per second. So that result is a good result. That means it is what? It is a standard one. It is not a so dense concrete, but it's a normal one. So this is how we carry out this test in the lab. In case you want to understand, so watch this video so that you don't miss everything that you need to understand about this test. Because just a matter of having your transducers or the probes, then you put it. If it is a direct test, as I've told you, you make sure that you conduct it opposite. You put it opposite to one another. But if I have to perform a semi-direct test, okay, that means I have to put it perpendicular to one another. I have to make sure that this surface is also smooth, so that I put it like this, okay? I put it like this, and then definitely the result is what? Is coming. So where the result is, it is actually at, you wait when it's almost constant, then there take 10.6, okay? So that is 10.6. That is for the case of a semi-direct test, when you have to put it perpendicular to one another. For the case of the third test is what? You have to put it on the same surface. That is for what? For the indirect test. Indirect test, you have to put both probes on the same surface. So that's how we conduct this test in the lab. this test is very important because it will help you know the correlations, the durability of your concrete, how dense it is, and if the result is less than 3 kilometers per second, that result is actually not good. So you have to do further tests, you have to do further investigation to see how strong that concrete is and how long it will take. Thanks so much. Don't forget to subscribe to Ultrasonic Engineering Academy so that you don't miss such kind of videos. Thank you. Bye.